So welcome to the second part. Is the camera rolling? Cool. All right, so this command I showed you earlier with curl that allows you to check your composer file against the PHP Security Advisories database. So they log all the different vulnerabilities, and you can just run this command to check your file and see what is potentially vulnerable in there. So let's just execute that command and see what it does. All right, so this is the command, and what you see here is you have a vulnerability. So CVEs are those vulnerabilities, and it tells you what the problem is in one line, and also it gives you a link to more details about this vulnerability. So there's a possible problem with HTTP Foundation. So they removed something, so you have to probably patch that. So this is just an example. So as you keep, like even if you already installed all of those packages, at any time you can go and check whether it actually needs to be updated. So you don't necessarily need to always, like every time you deploy, you update all your dependencies. Although you could, if your test suite is robust enough and you have confidence in it. If not, you can at least check whether there are any vulnerabilities that are known at least, and update as necessary. So you can cherry pick. Let us continue. So the 11th category includes XML external entities. Now, these are a bit trickier because it requires you to sort of provide your own XML to someone, but it depends what the application does. So if the application is asking you to maybe provide a link to an RSS feed, then you're in luck, because you can provide a link to any XML file and then start injecting things. So this is an interesting example. It's called, I think, attack of 1,000 laughs or 1,000,000 laughs. So the way this works, you see XML can have certain commands, like you can define an entity and you can basically assign variables, and then you can use those variables inside your XML. So in this case, what we do, I don't know if you can see it well, what we have is we have an LOL variable to which we assigned LOL. And what we do then is we create another entity called LOL1, and then we concatenate 10 contents of LOL. And then what we do with LOL1, then into LOL2, we concatenate 10 times LOL1. Okay? So basically we increase the power of how many LOLs we have in there. And we just keep going like that. And what's going to happen is when it tries to parse it, it's going to consume all of the available memory on the target machine. So when it tries to convert that to the actual string that it represents, it's going to explode. I think it's called an attack of 1,000,000,000 laughs. So it's a very easy one to do, and if people allow the processing of those entities, that's why they're called XML external entities. Well, these ones aren't even external, but those entities are quite dangerous. So if you just arbitrarily parse them and you don't know where the content is coming from, then you're open to an attack like that. So basically, this is a way to DOS someone. Okay, by increasing the memory needed. There are some similar attacks. So you would find this in many libraries, and you have to be careful. There's something called a fork bomb, okay, where in pretty much any programming language, you can replicate a process. You can fork the process, and you can do that as many times as necessary, and that's also going to exhaust the resources of the server. A zip bomb, also called a zip of death, it's an interesting one. So here's how it goes. You take You take a file, you create a file with just zeros in it, okay? And you zip it. And of course, because it is repeated, it's going to compress it very much. So it's not, the result is not going to weigh much. Okay, so you can take a 1.3 gigabyte file with just zeros and you zip it and it weighs nothing. And then you make 10 copies of that. And then you zip those copies again. And it still doesn't weigh much. And you repeat that 10 times, so very similar to the previous attack. You just keep repeating that and you increase the power of how many times you have it there. And the end result, the zip itself, is only 45.1 kilobytes. So it's really tiny. But then if you try to recursively uncompress it and have all of those zeros in your memory, it's going to represent 1.3 exabytes. So what's an exabyte? So you have the gigabyte, terabyte, petabyte, exabyte. So that's a lot of memory that you probably do not have on your server. And the point of that is you will probably not just randomly unzip files, but what happens is if you have a virus scanner running, it's going to try and inspect the content of the zip. And to do that, it's going to need to go through all the layers to see what's inside each of the zip. And as it gets unpacked into memory, it just becomes unbearable. So that is another way to DOS. Fork bomb, this is pretty simple. That's how you do it. You just fork the process, and that's it. That's a fork bomb. If you can achieve, if you are able to inject code like that somehow. I'm going to show you how to do your own injections that are a bit more complex. Because then you can have external entities, and that's where the fun really starts. So what we have here is, this is the code. Okay, so what I do here is, this is the XML string, and the XML string, okay, contains an entity here. This is where it's happening. It contains entity, remote, system, and then I go and I grab a URL. This is a GIST I created for you. We can see what it contains. Let's just open the raw thing. And that's all it contains. Really not much. This is a simple one. Okay, it says defaced, which means that when, let me just close Wireshark. When we are, quit without saving, when we are going to load that using simple XML, okay, and we allow entity loader, when we try to open that and try to output the product name, because you see what we do here is we create basically a variable called remote, and we put whatever comes from that URL into this variable, and then we use this variable here in the name, okay? And from there, what happens is it's displayed on the website, and it can contain pretty much anything. So it can deface your website, so you can have content that you didn't want there, saying some nasty things. So this is just a remote value, so it's not as nasty as, say, a remote XSS. You see, even Chrome does not protect you against that, because this is not as straightforward as the first example that I showed you. So it's going to say it twice, because I put it once in the title and once in the product name here. So same principle, it's just that the GIST here contains something else. The GIST here is pretty simple. It's just like HTML with the entities converted. And when you try to put it into the page, it resolves and creates that pop-up that you saw. And from there, of course, you can have a script that is as complex as you want, and it can be a keylogger, whatever. So as long as you read that and you output it, and you don't sanitize that, you have a problem, right? Yeah, so this is what the GIST contains. And it can get very interesting. Here is a file that I have, right, on the same level, of course, as the main script in the config folder, on the same level, we have a file. And see, it doesn't have to be a URL. It can be a file. And that's where things are interesting. You can basically take any file from the server that is parsing the XML and get it to be output in the variable. So this, minus the new lines, this is the content of a file. And if we go to the file system, we're going to, like in your file system, you're going to find this passwords. Well, in your case, might not be the same file. You have a different path. But if you put an absolute path there to the file that you have on your appliance, you can pretty much read any file that exists on that server. So that is quite dangerous, because then you can have access to anything. Anything that can be accessible by the user under which this process runs. Right, so if your Apache user can access that, or Nginx or whatever you're using, if that user can access this file, then you'll be able to read it and display it. All right, and do I have the example here? So the fix for that is actually quite straightforward as well. I will show you what you need to do. Luckily for us, in PHP by default, this option is disabled, but you never know which library you might be using, which might have enabled it on their end, and then you're getting in trouble. So XXE controller. So I'm going to show you what's happening here. Basically, all you need to worry about is this. So here we're using the libxml library, but in pretty much any language, pretty much any extension or library that you're using to parse your XML, there is a flag like that that you can activate or deactivate. And in this case, we say false to basically not disable the entity loader. Okay, so it's a flag. You just change that option, and if we just remove the line, this becomes secure. But the thing is, it may not be obvious to you because maybe you're using a third-party code that has that enabled. So you have to check for that. And once again, you can actually try and use Behat or a similar tool to test, to make sure that it is prevented by your application. Did I mirror or unmirror? So they are quite powerful. What can somebody do with an external XML entity? Well, they can inject all sorts of malicious content. It's very similar to XSS, where basically you can grab content from any third-party server and put it into the content of the page. If the data, the data can be parsed, not necessarily displayed directly to the browser. It could be stored in your database somewhere and then output. So you can store that injection and then output it for later. But it's still going to be the content of that gist, and therefore you are in trouble, because that gist could have contained anything. You can read arbitrary files from the file system, which is incredibly dangerous, especially if you're using some sort of production configuration file instead of environment variables. So you should read up on that if you're not using environment variables. There are actually, I think there was a lightning talk yesterday about how to dial it up even one notch up with by using, I think it's HashiCorp that has something for storing keys more securely even than environment variables. So look into that, and don't store any files with passwords on your file system. And of course, disable the entities. You can also do things like probe the internal network, see what's available. So remember, we can put any URL in there, okay? And if that URL exists, then if that IP address exists, then you know what to look for. And you can start probing the internal network, see what IPs are available. And of course, you can DOS by shoving dev random in there, which is it's endless, therefore will exhaust the system resources because it will just keep reading from there. So the solutions is not just because JSON is easier to read, but it's also by default a bit more secure than XML because it doesn't have all these fancy things, although it depends on the language. In some languages, I would not necessarily advise using JSON as a security measure. In Python, for example, you can also do some pretty nasty things with YAML. Well, JSON actually is safe. YAML is not necessarily, but yeah, JSON is rather safe. You have to validate and sanitize your input, so make sure that it doesn't contain any of those nasty commands that can read files from your file system. Make sure that you update your XML libraries. So simple XML you saw, it's very straightforward. Unless you explicitly activate that flag, it's disabled by default, but you might be going through like some more easy to use libraries, some helpers, and they might activate that by default. So make sure to turn it off and check whether your stuff is up to date. And yeah, basically the point is to disable external entities and DTD processing, which can also be used for some nasty side effects. Now, insecure deserialization. It's insecure deserialization, just like XML and everything we talked until now. It's its own category, but it overlaps with some of the other stuff. Pretty much, basically it says pretty much anything that you deserialize, any deserializes of any form, has some form of arbitrary code execution built into it, right? So YAML can execute some stuff. I'm going to show you an example with YAML. XML can execute some code. Everything you deserialize is, executable. I'm going to show you an interesting demo here with YAML. And we're going to have an exercise after that. PHP application. So I mirror my display and I show you insecure deserialization. So what we're going to do here is a bit like we did with the transactions earlier. We created a transaction for the purpose of the demo. So here's the list of files, okay, that I showed to you. This is what's happening on the server right now. If I create a config.yaml file, see it just got created here. Okay, and what we're going to do is we're going to deserialize this YAML here. So a bit like the earlier XML, with the product information, we have an ID and a name. But let's say I supply, as an attacker, I supply the YAML to you. And if you're reading my YAML blindly and don't notice this, then you have a problem. And this actually took quite some time to figure out. A lot of the examples you would find online sort of imply that you also have access to the code, which is not necessarily the case. But let's say we are using Symfony, right? So in Symfony, there's this class called File System Adapter. And I'm going to show you this class. It's quite interesting. Basically, this sort of attack requires you to probe the different classes a bit to see what's available. So this is how I found it. View, enter presentation mode. So this is part of Symfony. And I know the namespace here. What it does is, file system, whoa, sorry, wait. That's not the right one. I think I got the wrong class. File system adapter, yes. Oh, maybe in a different. It is correct. Where did it go then? Oh, it's in the file system trait, sorry. Because I cannot instantiate a class, I cannot serialize a trait, but I can do that for a class. So, is it here? file system common trait. I think that's where the interesting bit of code is hiding. Ah, yes. So the code I found, basically I looked for all the destruct and wake up magic methods, because when you deserialize an object, what happens is you create an instance with the state, and then at the end well, first of all, you call the wake up method on that, which isn't really commonly used. Destruct is more common. And when we exit the scope of the method where we deserialized it, we destroy the object because we haven't used it, and that's when things get called. Well, that's when the destruct is going to get called. So this particular class has access to this destruct method. And this destruct method, what it says, if I have a temp property and it exists, delete it. Oh, interesting. So what can we do with that? Well, here's how the attack goes. Go back to my controller, which is, sorry, not even the controller, to the browser. So what we have here is we say exclamation PHP object. This means that what follows is going to be a serialized, so in PHP if you call a serialized method on something, that's what you're going to get. So I just forged my own because it's just a string. So I told it, okay, so this is the class that I have serialized, and this is what it contains. It contains, so this is string, 54 characters, it contains that. And what you don't see here is at the beginning here and just before the TMP, there's a null byte, which is not a printable character, but it exists there in the file. I added it there. And that means that the TMP is a private property. So I can deserialize something having private properties injected into it. So I say, okay, we're going to deserialize, and the TMP is going to contain this, which is a relative path, which is going to work on your machines if you try this example. And so when we deserialize, what's going to happen? It's going to instantiate a file system adapter, okay? And the internal TMP property is going to be set to this. So when this object has outlived its usefulness, it will be destroyed. The destruct method will be called. And in the destruct method it says if TMP is not null, delete it. Delete the cache. But we can put an arbitrary file in here, arbitrary file name. So you see the config.yaml exists here. Okay, and when we deserialize, it's no longer there. It got deleted by deserializing this. So that's pretty nasty, because that means now you can go ahead and start deleting everything. Luckily, you cannot delete it's unlinked, so you cannot. Some permissions won't allow you to delete like a whole, /dub, but still you can do quite a lot of stuff there. And the reason we are allowed to do that is because we allow the parsing of objects. So similar to the XML external entity, it is something you have to explicitly activate. Some people might find it useful for some reason, but you might also use a library that has it turned on by default, especially in legacy applications. So check for those things. And if we want to fix it, and the way we fix it, actually I'm going to let you take a moment and find the controller called deserialization controller, and then you have the fixed version of it, and I want you to fix it and not allow the file to be deleted when you press deserialize. So yeah, go ahead. Are you guys working on that, or are you done, or are you skipping this exercise? Okay, you're still configuring. Okay, that's fine. All right, so the solution, as you may have noticed, is actually quite simple. It's exactly the same command as above, you just don't activate the flag. And you will find that in security, it's quite often a very simple fix. The hard part is knowing where to look, what exists. There might be some vulnerabilities that you may not even know about that are hiding in your code. So when you start reviewing, you will remember those flags and you look at them more carefully when you read especially legacy code.
And question, when you not pass the flags to the YAML parser, which kind of constants will be used? Because an example, I replaced the parser with dump. So the YAML parser does not parse the content of the YAML.
If you dump, the parser does not parse?
On the second parameter of the YAML parser, I just use the dump object, the constant.
Okay.
If I don't use the flag 0, and what's happened for my...
Oh, if you don't provide anything, nothing happens. It just won't allow it. You don't have to pass a flag.
Okay.
So basically, you just don't pass flags. It's not about... so as I said, the fix here is simple, but when you are looking at code that you're not familiar with and you see those flags enabled, then you have to think about the consequences of that. So you might want to remove that. This is why I stress a lot about auditing the code as part of your countermeasure. So you do have to know what's running on your server and how to fix it. So basically, yeah, you just want to prevent YAML from deserializing objects. It has very, I guess, edge case usefulness and a lot of trouble if you do activate it. So the vectors, basically any library that uses the native unserialize method underneath there somewhere, this is a possibility. So YAML is one example, but if there's a library that uses unserialize somewhere, so there's a possibility to pass a serialized object somewhere. If that input is not properly controlled, then you can have this problem. So anything that can call and serialize is your enemy. So you can call any destruct and wake up methods with any properties. As you've seen, it's not just public properties, the private properties are also deserialized correctly. So this is where it's really dangerous. You can upload rootkits to the server so that you can later access more stuff. You can silently just send data to third parties. So you can put something there that's, when it calls some requests, when it processes some data, it also sends a copy to some server where you can start logging all that private data. So a bit like a keylogger. It's just that it records any data that passes through the PHP script. And yes, of course, permanently inject keyloggers into templates. Just mess with the templates. Basically, you can do anything you want. If you find the right object that does the right thing in the destruct methods, basically you're still bound to the classes that are available. But if you're clever enough, you can find them and you can exploit them. And of course, those very large frameworks, they have so many classes at their disposal. Therefore, you can probably find something that can be useful. And then you can also alter the serialized data to upgrade privileges. So for example, some people might store a serialized user object in a cookie to pass it around. And if somebody can alter that, they can alter the serialized data there. So when it gets deserialized, the user has a different role. So you substitute the role property. So instead of being like a normal user or maybe even an anonymous user, maybe you can become an admin. And therefore, in your session, you'll have access to everything. So yeah, it really depends on what classes are accessible, probably through the framework. But one can do a lot of damage if used correctly. And for me, that was just one example. I found it rather quickly. And if I dig deeper, I can probably find more stuff. So the solution for that is you have to reject input from all untrusted sources. Okay, so you do not want to deserialize things from forms, databases, headers, cookies. Allow only primitive types. Okay, so don't allow objects in your XML or in your YAML. Just allow the strict basic types, so like strings and numbers and such, and booleans. JSON would probably help you with that because it only allows basic stuff. You can use checksums also to make sure that nobody has altered things while in transit. Okay, so maybe you are reading a YAML file from some source, but somebody put themselves in the middle and gave you another YAML to read. So you might want to have checksums to make sure nobody altered whatever you were sending. If you do need to run some deserialization operations, if you do need to use unserialize for any reason in your PHP script, independent of YAML, just you deserialize something, make sure that you run it using low privileges, because if the user that runs the unserialized command is able to delete files or write files, that's dangerous, because then this sort of thing can happen if there is a little hole in there. Then you might want to restrict network requests. So, when I said somebody can silently send data to third-party servers, or maybe even read from other servers, you can actually control which servers which other domains your server can request. So you can whitelist only the ones where you want to read from. You should also log any deserialization errors, and that will bring us into the next section. Deserialization errors should not happen normally, right? And if they do happen, it might be an alert to you that somebody is probing your website for vulnerabilities. They're trying to deserialize things that are invalid or that can cause harm. And if something fails there, because they need to try a few times before they succeed, if you get those deserialization errors, if you log them, then you can get alerted and see whether somebody's trying to get access to something, and maybe you can find the vulnerability before they do, if there is one. Or maybe you want to ban the user that's constantly deserializing it. And for the same reason, you would monitor repeated deserialization by user. If it's always the same user doing a whole bunch of deserialization, that also means that they might be probing your system for vulnerabilities. So you have to log those. And this brings us into the last section, which is insufficient logging and monitoring. And here's an interesting stat for you. In 2016, it took an average of 191 days to identify a breach. Not even fix it, just identify a breach. So people may have lost all of their passwords to somebody, but they don't know it yet. And they will know much later when they discover that their data is being traded somewhere. So, and that is, of course, because people don't log and monitor enough things. So the attacks start with probing, often failing. So I'm going to try something. Oh, can I do 1 or 1 in the URL? Is it going to show me something, something interesting? Oh, no, it doesn't. Let me try something else. So you have to try things and see what's available. So this will generate all sorts of errors. And you have to have a smart monitoring system that can catch those probing attempts. And you can say, okay, somebody's trying to get into my system. So an example would be, have you ever had bots scanning your, like you're getting a lot of 404s, and that's because a bot is trying a whole bunch of URLs, often with like WP admin, right? WP admin in your logs, lots of 404s. Even if you don't have WordPress, you're still gonna get those bots trying to scan you, because they expect that a lot of websites are running on WordPress. So they're going to try. They're going to try different URLs and see what's available. Or also PHPMyAdmin. People try that a lot. They try to see if you have a PHPMyAdmin installation, and then if it doesn't return a 404, they'll know, and they're going to try to attack you through that entrance. So you have to monitor that. You have to monitor to detect that kind of probing. Also, if they're trying to connect using different ports, you have to have some smart system in place. So you have to also guess what the attacker, the attacker was trying to achieve. So you look at the logs and you see something weird, and you're like, what is this person trying to achieve? Is that something that's actually dangerous to me? If they had more time, would they have succeeded in finding something? Should I maybe look as well? Because if they're probing for something, maybe they'll find it, right? So if they're trying some weird URLs, like, oh, am I actually vulnerable to that? So you have to be first on the scene. Hopefully you will discover your vulnerabilities before they do, because sometimes it can take them weeks to discover something. They try different things. First they go with like automated tools, and then when they're onto something, they start going in manually. And of course you have to log. So monitor is basically what you do is you pop alerts. Like you don't physically look at your logs all the time. What you want to do is have some sort of alert that says, hey, this URL has been accessed a gazillion times in the last minute, where in general it's not accessed that much. Something's up. So you need those sort of filters there that will alert you, send you an email like, hey, something's up. Your CPU usage is through the roof. What's happening? Maybe or your memory usage is very high. Maybe somebody's doing like the attack of 1 billion laughs with the XML, LOL variables, things like that. So you have to try and understand what's happening. And what you want to do is have a lot of logs. Like, not something that will slow your website to a crawl, because of course you need to have a good balance. But what you want is to understand the attack. When an attack does happen, when somebody is successful with an attack, and you have insufficient logging, what happens is you are unable to reconstruct the attack. You are unable to understand it. So it happens to me quite often that clients call me and they ask me to come in and look at why their website is so slow. 9 out of 10 times is because they're getting denial of service attack, but sometimes it's legit. Like they deployed something and something's wrong. But yeah, when those attacks happen, often these clients, they don't have sufficient logs. So I have no data to work with to understand what is actually happening. Is this a legitimate issue with the application? Did they push some update that is causing some lazy loading and stuff? Or it's somebody that's actually trying to attack the website? And the problem with logs, you can see, for example, if I ask the question, when has this started? If people don't have logs, then they cannot answer this question. Like, when has your CPU started to spike? I don't know, I guess it's been going on for a month. I mean, it's not very precise. You need to know why, and you need to know what URLs have been accessed, at what frequency. That's how you understand it. And maybe you can even find the attacker. If you have enough logs, you can eventually reconstruct everything and maybe even find the person. I mean, that'll be the ultimate thing. It's always fun to find the bad guys. But at least if you can understand the vulnerability, then you can prevent that in the future. You can fix the immediate problem and prevent those kind of things in the future. So for example, if somebody is doing too many requests, you can have like some fail to ban rules, and you quarantine them, and then if they persist, you just ban them. So examples of those kinds of attacks in the wild. For example, I've seen, and this is like real clients that call me. I'm not going to name names, but in large organizations usually, people have no alerts when database attacks, database backups fail. So they have like a backup, and they're not doing the checksum. They're only doing like torn page detection. So it's like one level below, so some sort of database corruption can occur in their backups and they would never know it. And even if those backups fail, they don't get any alerts. So you could have, for example, you may have skipped a month's worth of database backups and you might not know it. And so of course, if then somebody does like a ransomware, they steal your database and delete your own, you don't have any backups to start back from. No brute force attack detection. And brute force attacks are interesting because there's a different types of brute force attacks. People assume that a brute force is somebody picking a username and just repeatedly trying a bunch of passwords. It does happen very often. It's the most common case, but it's not the only one. I've seen something very interesting where people steal a database of passwords, decode it, or maybe intercept some stuff using, if it's not HTTPS, they intercept a bunch of plain text passwords. And what they're going to do with those, they're going to use that combination of username password on a bunch of very popular websites. Okay, but they're only going to try one username per site. They're not going to repeatedly hammer that username because they already have legit credentials that the person might have reused on another site. So they try that pair everywhere, but you should still detect that, for example, a bunch of login attempts for different users are happening in quick succession from the same IP address. Okay, so that means it's not the same account that's getting attacked. It's somebody trying to log in into a whole bunch of accounts, and it's the same person. Why are they doing that? So you should think about all of these scenarios. For example, no DDoS detection. A lot of the time, they don't have any sort of alerting in place. So when all they know is that suddenly their website is incredibly slow. And I've had that so many times, just in the last year, 3 clients for that. A DDoS attack, and they had no idea it was happening. All they know is that it's very slow. And they don't know where the attack is coming from. They don't know it's an attack first, and then they don't know where it's coming from because they have no logs, they have no alerting system. You have to URL scanning, as I said, about PHPMyAdmin, WordPress installations. They're going to try and check your URLs, see what's available, see if you're running any common software that can have known vulnerabilities, and then they can go from there. No alerts in case of CPU spikes. That is a bit more rare. Usually people do have alerts for that, but very often also they just realize that their website is incredibly slow. Like their customers are complaining that the site is slow. On Twitter, for example, oh, the site is so slow. Oh, I didn't know that because I don't have any monitoring in place. No alerts in case of application errors. Application errors are not normal. Okay, so if you are going to log them, you might as well alert about them. Of course, the problem with some people is that they will not fix all the common problems, so they're going to get spammed with alerts. So they're going to get like 500 emails per day with all sorts of application errors, and they're going to start ignoring them because like, oh yeah, we know about this error, but we're not going to fix it yet. Yeah, well, there goes your problem. I see the face. The problem with that is then basically you get overwhelmed and you stop caring about it because if everything's a problem, nothing is a problem anymore, right? So what you want to do is eliminate those application errors because then you can see the real stuff happening. So then when you do get an error, you can actually take it seriously. I was working at a company about a year ago, and we had this policy. We said any production error is very important. Basically, stop doing whatever you're doing and fix the production error first. That was like top priority, no production errors. Because otherwise we wouldn't get those alerts and we would lose customers, and it's pretty bad for business. And log management. There are lots of interesting tools that you can use to centralize your log management. So your database logs, like MySQL logs, like monitor a bunch of variables, see what's happening there. Are you doing a lot of full table scans, is that gonna hurt your performance? I mean, it's also important to think about your application as a whole, not just from the security side, but it does help you for security as well. So centralized log management like Datadog or equivalent, that will be very helpful. So examples of things you can log, because people say, yeah, log everything, but what am I actually logging? Okay, here is a non-exhaustive example, a non-exhaustive list of examples. Fail attempts to log in, rotating brute force, like I explained earlier. Just have a pair of credentials for different accounts, not necessarily the same account. ACL errors, if user A tried to access user B's transaction, so instead of /1, I put in /5. How did I arrive to this page? Did I manually input that? Did I try to break the system? If you have a log for that, then you can try to recreate it. Okay, and if somebody's indeed trying to break into your, is indeed probing, well, maybe you can just block that user because you don't need that person on your site. Any 404 and 500 errors, 500 errors, you take them seriously. 404s, you log them, but then you put some rules in place where you set some sort of thresholds and then you alert yourself. Input validation errors. These are also not like 500 errors, right? It's just a user who has input something bad into the form. But what you might want to do is still log them so that later, when you do have an attack happening, you can go back and see what somebody has tried to do. So if you do get hacked, for example, through a form, if somebody is successful, you can recreate the attack by looking at failed validation. How did they get there? What did they try? What kind of input did they try? And if you do have that log, it's actually pretty useful. Recreating the attack is extremely useful. Also, make sure that you log with some context and keep for a rather long time, because as you've seen, it can take up to 191 days, well, on average, 191 days to identify a threat, an attack. So you might need that for later forensics. So logs are rather cheap. Use some tool to aggregate them, monitor them, and you can then go back to any point in time and look at what was happening in your application. And of course, you can do a pen test to see if your logs provide sufficient data about an attack. So basically, you create a sort of, you like fake an attack, even if you fail, of course, because you have security in place. Let's say you try an attack and you see, what do your logs say about this attack that you attempted? Does it give you enough information to then understand, to then recreate what the attacker did? So like hack yourself to see if your logs tell you anything about the hack. Make sense? Yeah? So yeah, as I said, you can use an aggregator like Datadog. That's the one I've always used, but feel free to use any other tool. Add rules to detect any suspicious activity, alert if there's anything happening, and can also use to spot other things like performance issues, so you get like a 2-for-1. There was the thing, as I said, you can monitor certain database variables, for example, like full table scans. If that suddenly spikes, so it gets way above normal, suddenly you have like a million times more full table scans. That means some indexes are not used properly. Something happened to the structure of the query that is now causing this. And I've seen a large website being brought to its knees after somebody deployed a patch, like they implement a new feature, and the query was executed using different rules, and then an index wasn't used. And they couldn't detect it. They couldn't find the problem because they weren't logging that data. So it can be used to spot them. Then you can spot a problem maybe before it becomes catastrophic, right? So a CPU spike, don't wait until it's like at 98%, right? And if you have triple the full table scans, I mean, it's not bringing your site down. but it's a warning sign that maybe something's amiss. So do something about it now before it becomes catastrophic. So that's it for the common coding vulnerabilities. And now we're going to go to the next section. So regarding those vulnerabilities, what you want to do is avoid discovering them in production as much as possible, or catch them really early. So you do code reviews, penetration testing, and you can also follow security news, like mailing lists, some Twitter accounts. So just follow people in PHP security that, whenever something happens, they're going to tweet about it. So you'll know that something's happening right now that's really important to fix, like breaking news, And what we're going to talk about in the next section is threat modeling. It's a bit more involved, and you really need to set some time aside for that. So, but however, it is very important to do that, because if you don't do that, you might end up like you get really excited about security and you try to fix everything at once and you don't prioritize things correctly. So you might end up fixing something that is of little consequence while missing something much bigger. So you have to prioritize them once you do start to audit your code. Because if you do take the time to review your code, you're going to find things. And a little extra for that, you can also adopt an incident and response and recovery plan. So there's an example on this link, and the slides will be posted on the Slack channel. So as soon as we're done, I'm exporting to PDF posting, and you'll have a link so you can click on that. It's a PDF from the NIST, from this institute. So this is one example, not necessarily from that guide, but this is one example of a response plan. So what does a response plan look for? What does a response plan looks like? Let's say you have leaked passwords. Do you have a response plan for that? I mean, ideally it wouldn't happen, but you still need a plan in case it does. Like, you don't plan on falling down and breaking your ankle, but you still need to have a response plan. Or maybe you fall sick, you don't plan for that, but it happens and you need the ambulance to arrive. So what you can do is a one-click process in case that happens. The concept is when you know that your passwords have been leaked, okay, the news just broke, your passwords are now available to everyone for everyone to see. Even if they're properly hashed and everything, what you do is with one click, you log out all users. Just terminate all the sessions. Okay, next time they arrive on the page, they won't be able to perform an action. They're going to have to log in. As you log them out, you mark all the accounts as compromised. So let's say you have a column in your table. It's called is dirty, and you set it to 1. Okay, so now all the accounts are marked as compromised. When an account is compromised and the user tries to log in, you force a second factor authentication, like a Google Authenticator or SMS or some other method to double check their identity. And once they went through that process, they're still marked as dirty. So now you're going to force them to change their password, because their password is compromised, right? I mean, yeah, it is them, but their password is floating around. So you ask them to change it just in case, so that whenever the people manage to decode the plain text version of their password, it will no longer be valid. Okay, so you force a password change, and as soon as all those steps are complete, that particular user who went through all those hoops is going to be marked as not compromised. And this way you slowly bring all your users up to speed, so nobody basically can use, so the database was leaked, but is now completely worthless. Right, because you have this response plan. Because when the news breaks out, you're going to have so many things on your hands that it's not a good time to start thinking about the emergency plan. You want to have the emergency plan before things go bad, because you're just going to be overwhelmed. What is threat modeling? It's a procedure for improving your security. what you do is you identify your assets. Okay, assets are, data you possess, things like that. Identify your assets, and then identify the threats to those assets. So what is going to cause a threat to them? You then identify those that are potentially exploitable. Some of them are theoretical, right? Well, there's a theoretical threat that a meteor is going to fall down, but maybe we don't necessarily need to plan for that. Maybe we do, I don't know. Depends on how protected you want to be. So you find the ones that are potentially exploitable and you prioritize them. And then you look at countermeasures, and based on all that information, you start with the highest priority. So you classify them, prioritize, okay, we're going to address this first, because you actually have a methodology to prioritize them. And you take the top one and you start with that, and then you move on to the less valuable ones. So basically they prioritize like a backlog of security countermeasures that you want to implement. So what you want to do, you want to either completely eliminate the threat or you want to mitigate it. Okay, so you want to bring it down to an acceptable level with which you will be comfortable, so you don't need to go further. Because some of them can be very expensive and basically have a low return on investment. Sometimes, for example, let's say a credit card, they don't mind if there's an occasional fraud. Like up to a certain level, they're not too worried. Like if somebody steals $10, it's more costly for them to try and prevent it than it actually costs to lose that money. So it costs more than $10 to try and prevent the loss of $10. So they might not implement certain security measures. I know that my credit card, when I purchased the first plane ticket, it works fine usually. And for the second plane ticket that I buy, if I do like a multi-city trip, for the second ticket I buy, it sends me an SMS saying, here's the amount that somebody tried to process to my phone. So that's like a second factor authentication. They send it to my phone as an SMS and I reply with yes, and then I can try the transaction again for the same amount and it's going to go through. So that's a cool feature. But they only do it above a certain amount. They don't bother with like $10 transactions. And they don't lock down my card, which is nice. So the threat modeling process. First, you have to understand the types of threats that you have. So now that we've seen all these categories, how do we put all of that together and how do we make an actual plan? So you have malicious threats, like DDoS attacks, people trying to steal your data, things like that. And you have incidental threats. And you also have to consider them because it is part of security. It's just, stuff happens. Like a storage device failed, backup didn't work, whatever. Storage device actually is a very common problem. And then you have to understand that each technical decision that you make is going to introduce a potential threat. Do I choose this framework or that framework? Well, depending on the framework, you might have different threats. Now you have introduced a threat of some sort. Now you have chosen this library, you have chosen this extension, you have opened the port. Every decision you make, how long are my API keys? I don't know. All of that introduces a potential threat. So the thing that you then have to understand about those threats is that some of them are either unlikely, like a meteor. In some places, earthquakes are rather likely, so you might want to plan for that. You might want to plan for the destruction of a full data center. So you might want to have that in different geographical regions for redundancy. But some of them are a lot less likely. Or they can be very likely, but they have such a low impact that you don't really care. And you have to be able to assess that impact and the likelihood. And here are the steps. So I talked about identifying the assets. One of your assets is a database, right? It contains a lot of valuable data. Then you have maybe some sensitive files. Maybe you store some forms for tax returns and stuff like that. Your reputation is an asset. So if something bad happens, people are going to tweet about it, it's going to hurt the reputation of the company. Like even if a site goes down during like a big sale, a lot of people are going to be on the site, it's not going to work properly, they're going to be pissed, they're going to tweet about it, and everybody's going to know that there's a problem with your business. So your reputation, you need to protect it. You need to protect your customer base. You don't want customers to move away from you, switch to a competitor. The relationship with your employees is also important. It's also an asset. So if you have a good relationship with your customers, with your employees, you want to protect that because it has value. So the assets depend on the type of business you have. Like sometimes maybe human lives are an asset because maybe you do something, I don't know, with the FBI, and if an informant, if data gets leaked and the informant gets killed because the safe house is known, then that's a problem. Identify threat agents and possible attacks. So who are threat agents? Can be different ones. Insiders, so people who are inside the company. It can be staff, so all sorts of employees, contractors, vendors, people who have some sort of access to your systems, right? So they have like privileged access. They can be insiders, they can be outsiders, people from the outside, competitors, criminals, activists are actually a big threat. And it can be all sorts of people who are unhappy with you because maybe they perceive that you wronged them somehow. Maybe you are a website that does reviews of video games and you gave them a bad review, so now they're going to go after you, and they're developers, so they can do stuff. So these insiders and outsiders, those are the two categories, and they can perform malicious attacks or they can make honest mistakes. Like, who here has dropped the wrong database at some point? Once? Twice? Come on. Not me directly, but a colleague of mine, and I saw the face, and it was horrifying. It's terrible. I know that when I do like those Zoom meetings, to pair program, and somebody's like moving quickly between two tabs to copy things from one database to another, I'm like, can you double check that you're on the right server, just in case, because I've seen this happen so often. So yeah, people on the inside can make a mistake, but you might have countermeasures to prevent those mistakes. Maybe you don't want to give people the permission to drop a database. So even if they do make the mistake, there's like a safety net. And of course, there are other agents that are not people, they're just unfortunate things that happen, fires, earthquakes, malware. I'm saying it's unfortunate because it can just spread indiscriminately, so you're not necessarily the target, right? If something just starts going through a network and just infect all the machines, it doesn't care if it's your server, it just spreads. It's like a virus, it doesn't care. And then you have to understand the countermeasures for those threats. You can eliminate completely, you can prevent, so you can block them, or you can minimize the harm. So this was already mentioned in a few ways. So here are examples of countermeasures. One action is security training. So this is actually one countermeasure because you learn about things. You can update your operating system. That can close a whole bunch of vulnerabilities. So you have to do something concrete, like you have to act. So, okay, I'm going to check my composer file. I'm going to see what's happening there. Are there any known CVEs for that? Are there any known vulnerabilities? It can be a device. And of course, the term device just means a means to perform something. So it doesn't have to be physical. It can be like a firewall appliance, intrusion detection system, all sorts of devices. Procedures, such as code reviews, so you put procedures in place. Okay, so before we merge that pull request, another senior developer should review the code, any senior developer, or you maybe need the approval of 2 reviewers before this is merged. And by doing a more thorough code review, you are ensuring that there's less chance that something gets through, right? And like every place I see that has like these code reviews before PR is merged, it's wonderful. They spot not just style issues, you know, like indentation and how you should write it, but they spot like security, potential security issues, potential performance issues. So these are the things you should look for, really. Maintainability concerns, things like that. You can have a procedure where you remove unused SSH keys, or maybe you want to have like roles that grant certain access. If you revoke that role, it's going to remove all those accesses. Instead of manually, you know, granting this and that access, you know, like, okay, here's access to the our internal package repository, right? Because some people have that. They have their own packages that they reuse in larger corporations. So you have access to this, you have access to some, you know, Jira and whatnot. So all these accesses can be maybe revoked with one click. So that is a procedure you want to put in place so that you can, first of all, easily grant it. So that's very nice for onboarding, but you can also very quickly revoke it. Because how many times I have to email my clients after I finish the contract? It's like, it's a 1-week contract, and then weeks after that I'm like, oh, I still have access to this file on Google Drive, and yeah, you should remove that access. Oh, I still have access to the server. So I actually have to double check that they have removed my access, because I don't want to have that access. Because then I want to be able to say, no, I'm cool. If there is an intrusion, I can say, no, that wasn't me because you removed access. And technique, that's like what we developers do. We can validate the input, encrypt data. So those are the kind of things that we've mostly learned today. Now, I need more water. So it sounds a bit heavy, but we're going to do exercises with that. So we're going to make this interactive, and we're going to go through this process and try to come up with real examples. And we're going to do this together. So you have to identify the vulnerabilities that are exploitable. So you have to search for those the vulnerabilities that connect the possible attack to the negative consequences. So an example is, well, we are storing credit card numbers in plain text. What is the negative consequence that this leads to? Does this actually lead to a negative consequence? Yes, we have loss of confidentiality. Okay, so that is an exploitable vulnerability. And then we have to calculate risk, okay, and we prioritize. So we have to, basically a risk is you consider both the likelihood, how likely is this to happen, and the impact, how bad will it be if this actually happens, right? So if, let's say, the likelihood is medium and we estimate the impact at high, then the overall risk will be considered high, right? Because it has a lot of impact. And we'll look at how to estimate that in a few moments. There's actually a whole methodology to that. So then we identify the countermeasures to reduce the threat. So once we have prioritized the ones that we want to address, we look at what will it take to reduce the risk to acceptable levels. Okay, so maybe we cannot get too involved, and we can maybe do like a halfway solution that is going to be rather cheap, as opposed to a much more involved solution that is not going to have that much benefit if we implement the full thing, right? So you might not need all the bells and whistles. It's really, the threat is not something that's absolutely, you cannot possibly bring it to zero anyway. So, and it's really easy to get caught in this and waste countless hours. So you have to be mindful of what is a risk that you're willing to accept. maybe like I talk to my clients sometimes, and they can accept certain risks. They're like, yeah, we can have this kind of mistake happening from time to time, but that's actually acceptable because it's so cheap for me to fix it manually that spending like 100 hours on that trying to fix it in the code, it's not even worth it. You never know, so you ask. So an example, if you bind SQL parameters, you're probably bringing that, if you have a possibility of SQL injection, then you're probably bringing it to a rather acceptable level and possibly eliminate the risk altogether. You have to be, so regarding this, so I mentioned maybe things, like I talk to you a lot about, doomsday scenarios, but at the same time I tell you not to worry about everything too much. Basically, the rule of thumb here is be pessimistic, like I'm quite pessimistic, but also be pragmatic. So find a good balance between pessimism and pragmatism. Because if it's not pragmatic, if you're just gonna spend 2 sprints doing something that has very low value, it's not worth it. So the methodology, and I want you to participate, this is an official methodology. And what we're going to do is we're going to think of various threats. We're going to identify, classify them, and I want you to participate. So we were talking about the risk rating methodology. So let's think of some assets. What assets do you have based on what we talked? What are your assets? Database? File system? Let's do this. I know it's hard, it's the last day, but we'll manage. Assets, database, file system. What do you have on the file system? Your application code? Okay. The server, physical server. Okay. Other assets? Network. Okay. What else? Where else can you have sensitive data, maybe? Configuration. Okay. Where is your configuration stored? In a file or in environment variables? Yeah, so env. Okay, good enough. We can start with this. Huh? Cache, okay. Yeah, there can be valuable things in the cache. What kind of valuable data do you store? What? Processed pages? In the cache, okay. What sort of data you wouldn't want people to steal? What kind of data do you have that you don't want people to steal? Credit cards? Do you have those for real? No? So that's theoretical, okay. Personal data, okay, example? Okay. So PII, personally identifiable information. IP addresses, their location maybe. Okay. Any other sensitive data? Passwords? Huh? Invoices, yeah, that's something that you don't want people to get. Invoices, passwords. Okay, we'll start with this. We'll pick a few and we'll look at the threat engine, agents, and attacks. So who would want to, let's say, steal your invoice information? Who would that be? And how would they do it? Yeah? But who's they? Competition, okay. Hmm?
Maybe some, for example, the hackers, the activists.
Activists, okay. Okay, we'll start with competition maybe. A bit simpler to qualify. So, competition. And how will they access those invoices? Where are the invoices stored? In the database, yeah? Okay. File system, okay. So maybe DBFS. Okay. And how, let's say it's on the file system. Maybe you cache those invoices, those PDF invoices. How can they attack that? Yes. Actually, let's create a whole section for that, and let's look at that one in more details. So, let's start with invoices on the file system. Competition. URL in browser. That's actually pretty straightforward way. Okay. What other ways? Okay, so they first have to gain access to the personal account? Yeah, session hijacking. Then it doesn't matter where it's in the file system. So, session hijacking? Huh? Good old SQL injection, yeah. FTP. You know, sometimes people, they have this old system where they want to have FTP access so they can edit the templates. The client can edit the templates themselves. So FTP. Other ideas? Oh, XML external entities. No, wait. That was that XML? Yeah. All right. XSE. SSH attack. How they? Okay. Will they have a key? Okay. Let's explore that as well, because maybe we'll find that maybe it's very likely or unlikely. So through SSH, sorry. Good enough, yeah? We can start with this? All right. Now, we have to think about existing countermeasures, because if the countermeasure is very simple, we can just go ahead and implement that. And maybe one countermeasure can be used to protect most of our assets, right? So what would be, let me just separate those out. What would be the countermeasure for the URL in browser? Okay, so vhost configuration. Okay. Whoa. So vhost. That looks like a 5. Okay. That's a pretty straightforward way. Okay, let's do it. Session hijacking. Okay. Regen SID. Good. SQL injection. Sanitize the input. Okay. Input. my writing gets worse and worse. Any other ideas for the SQL injection? You already gave enough answers. I want others to participate. Anyone else? What did we talk about in SQL injection? How do you protect against that? You can bind your parameters, right? If you do that, it's a bit harder to get stuff. Bind parameters. Okay, FTP. Thank you. I was hoping somebody would be so straightforward, you know. Close it. All right, XXE, close it. Or turn it off. Turn it off. If it's turned off, nobody can use it, yeah. SSH, well, you cannot turn off SSH. What can you do about SSH? Okay, clean up keys, yeah, that was your ideas. Huh? Yeah, use keys, that's actually a pretty good one. Use keys and clean up keys. So what he's saying by that, and it's not part of this presentation, but another one, I have this interesting story where there was a client who he actually was in the fintech industry, and he decided that my services were too expensive, so he went to some website where for $5 you can get anybody to do pretty much anything. So I don't know, I guess it seemed like a good idea to him. It's like, oh yay, somebody's gonna work for free. And he gives that person root password. Password, of course. And so the person went and did some damage. And the problem with passwords is now you have to change them, right? So even if you do manage to close the gap, those passwords, somebody else can have the password, so you cannot just, you have to change that. And if you have multiple people accessing the server for all sorts of maintenance, well, now you have to resend all those passwords, or that password to all those people, because you probably have like one root password. So the solution is to use what's called SSH keys. So SSH keys is basically if I generate a key on my machine, that is like the password, and it's stored on the other side. So there's a private version, a private side and public side. So I can give the public key to the server, and we add it there, and that authenticates the session. So basically you have a file called authorized keys. So I'm talking Ubuntu, of course. Might be slightly different on other distros. So you have the authorized keys, and you just add them one per line, and when something is no longer valid, you just delete it from there. So it's very easy to maintain. It's like you deactivate users. So you only cut the access that you want to cut. Okay, makes sense? So first you use the keys, and then you make sure to clean them up. And if you have some sort of automated system for managing all of your permissions at once, turn off all accounts everywhere on all the sites, and also delete the SSH key. Like this developer is no longer a developer, so at this company, so let's just close everything down. The more you automate that, the better. Okay, so we have a few countermeasures. Now, which ones are exploitable? Like, which ones we think people are going to try and use? And which ones are more likely to succeed? Okay, URL seems simple enough. Actually, pretty much all of them are quite straightforward. Maybe SSH a bit less so, it's a bit more involved, unless you happen to have a password. But most of these are quite exploitable, depending on what they have. If they have FTP, then of course you're in. Okay, we're just gonna go to the next one. Yeah. Okay, so actually let's do a survey. Okay. Do you believe that any of your systems is vulnerable to this? How many hands? Do you think you might be at risk? So 1, 2, 3? No? Are you just dusting off stuff? You're not sure? Maybe, okay. Okay, 3. I mean, it's okay. It's not, we're not judging here. 3, it's probably not your code, so it's okay. 3? Okay, so let's put 3 dots maybe, like little votes. Okay, basically what we're trying to assess here is your system actually at risk? Is it something that's possible? Because then if it is possible in your system, if you do have that vulnerability, then we're gonna need to start and classify that, okay? So do you think you're at risk of session hijacking? Do you regenerate your session IDs? You do regenerate? Or you don't? You think you might not. Okay. Do you, everybody else, 2? You're not sure? Okay, that's fine. 2? Possibly 2? Okay. We'll go with 2. All right. SQL injection. Do you sanitize input or do you bind parameters? All of you do? Okay, so this is not really, very likely in our case. 1, is that like a pity vote? Okay, you've seen some stuff. Okay. FTP. 1, 2. Is that like you cast 2 votes, or is that like a cultural vote? How do you raise hands in your culture? With 1 finger, 2? Okay. 2? Okay. Where are you from? Poland. Okay, so Poland is 2 and here is 1. Okay. So we have 2 FTP. 2. Sold. All right. XXE.
I'm not sure if it's disabled actually. So I know the bots are several, a lot of XML stuff.
You do a lot of XML, so might be. 1, 2, 3. Okay. 1, 2, 3. SSH. Do you use SSH keys? Yes? Okay, so this one is not likely. Okay, so we're just going to cross it out. All right, so let's start with those 2. Okay, we'll try to classify 2, and if we have more time, we're going to go over the other ones. Because it is a bit of an involved exercise. But then you're going to get some practice. Okay, so the next step is going to be rating and prioritizing. Okay, and then we're going to look at which countermeasures are worth implementing. So in order to rate and prioritize, you need to understand 2 things. You need to evaluate the likelihood. So there are different contributing factors that increase the likelihood. One of them is based on the threat agents. So the factors come from the threat agent itself. So we talked about competition. So this is our threat. Your competition. What is their skill level? So, for example, if they have no technical skills, we're going to give it a 1. If they have some skills, we'll give it about a 3, on a scale like that. And if they're like they have programming skills, then it gets better. And then if they are hackers, basically, if they have security penetration skills, then we're going to give it a 9. So from 1 to 9. Okay, so your competition. Who says their competition has no technical skills whatsoever? Like, think of the most likely competitor to what you're doing, okay? And do they have people with security penetration skills? Yeah, okay, 1. Okay, so there's lots of categories to go through. We'll start with one, the URL in the browser, and we'll just go from there. So the skill, we say that possibly our competitors have some security penetration skills, so we're going to put a 9. So our competitors are quite skilled. Okay, do they have a motive to do that? So is there any reward? Is it like low rewards, average reward, high reward? If they manage to access your invoices through the URL, how big is the reward? How much are they getting out of it? Huh? Okay, so you're gonna give them all your client base so they can contact them. The invoices have possibly email address or something. Yeah, direct marketing. So if they have a phone number, they can start calling your customer base and try to offer undercut by $1 or something, or by a kuna.
They can know your sales profile, so how much, what you're selling and what.
They can get your sales profile. They can know what you're up to, how much you're selling, what kind of services. So they can get a lot of information. So the reward is, we'd say, high, average. Average. Who votes average? 1, 2. High reward? 1. Okay, we're gonna put it says here 4. We can put a 5. It's very it's not a very precise science. It really depends how you feel about it. It's just to give you an idea. So let's say 5, average. Now, do they have the opportunity? So the opportunity means, of course, they are external, so maybe they have fewer opportunities. An internal threat would have more opportunity. So opportunity means, do they need some specialized resources, or do they need no resources at all? Is it like very simple? They don't need like lots of GPUs, to calculate a bunch of stuff. So URL in the browser, how many resources does that require? Like 0? 0. Okay. So the opportunity is super simple. 0. What is the size of this group, this threat agent? How many people are we talking about? So when we talk about size, we're not talking about number. We're talking more about profiles. So like anonymous internet users, basically it's free for all, right? Do people need to be authenticated before they can access this? Do people need to be authenticated to view invoices? No? Okay, because we just stick a URL in the browser and we access the PDF. So they can be anonymous internet users. So that basically means everyone. Excuse me? Well, that's what we're trying to assess. We're doing the exercise. If we find out that we are potentially exposing our file system to the world, okay, because we didn't secure it correctly. Remember in one of the first examples I showed the good and bad configuration of your VA host? Say you don't protect it. So this is just for exercise, right? I mean, in real world, maybe you might just say, we'll just change the configuration and be done with it. It's faster than go through this process. But this is mostly for exercise. But yeah, I mean, once you spot it, you'll probably just fix it. So the size of the group is anonymous users. They're not like, if it's developers, then it's a small group. If they're like intranet users, it gets larger. Partners maybe slightly more. So any authenticated user, people can create accounts. But anonymous internet user, basically you can get spammed from anywhere. So the size is going to be fairly large. Okay. So that's the first list of factors. For likelihood, there's a second category we're going to use. It's called the vulnerability factor. So the vulnerability itself. And you can already see where we're going with this. We have discovery, or ease of discovery. We have exploit, how easy it is to exploit this. Awareness, do people know about your vulnerability? And detection. Do you have something in place to detect them? Because that just makes it more likely. If nobody's going to know that you were there on the server, then it's not. It's a bit more likely because there are no repercussions. Right. So, how easy it is to discover something like that? Are there automated tools available for that? Okay. So we would go from like practically impossible, difficult, easy, and automated tools available. So maybe there are tools that somebody can use. Maybe input some pattern and start scanning. So we're going to put the ease of discovery 9. It's probably one of the first things I would try too. Well, it depends on, so the question was if the naming pattern of the file includes like the username, then maybe first you have a list of usernames, which is actually quite feasible through if you want to reset passwords or if there's some enumeration. Or you can just go and brute force because it's quite cheap. If there's no logging, just brute force a whole bunch, right? Yeah, once you know the pattern, you can create a generator. So you know how long the usernames are and you just start trying them all. Yeah. So, so now, how easy is it to exploit it? Is it a theoretical exploit? Is it difficult, easy, and again, automated tools available? Can you write a script to just download all these things? Yeah? Yeah, I would probably write a script. All right, awareness. How well is this vulnerability known to this group of people? How aware your competitors are about this thing? Do you think they know that you might have this vulnerability? Okay, so you would say it's public knowledge that such a common vulnerability, they'll probably just start there? If they have their own account there, they'll just click a link and they'll see the invoice pattern and they'll start working with that. Okay, so awareness, rather easy to find out. Okay. Well, actually, I would put 6 because it's obvious, but not necessarily known, because then we sort of overlap with the ease of discovery. So I'll just put a 6, if that's okay. I have your permission, yes? All right, and now we're going to talk about intrusion detection. Do you have active intrusion detection in the application? Do you check for URL scans? Do you log your 404s? Yeah, but you're still going to have 404s thrown by the server when it tries to serve the file. Yeah, yeah, but that's the countermeasure. So the intrusion basically, unless you are actively logging this and monitoring for that kind of intrusion, then it's a bit less likely for the person to be detected. Like, do you have active detection? Do you log and then sometimes review the logs? So you might stumble upon it occasionally. Maybe you log, but you never check your logs, so it might be much harder to detect. Or maybe you don't log your 404s. Do you log your 404s? Yeah? Okay. So some people log. From those who log, do you review your 404s? So at least one person does. So let's say it's logged and reviewed, so we can put a 3. Okay? All right. And this is why the category for logging and monitoring is quite important, because that reduces your likelihood, especially if other people know. So that's one part. And the second part is the impacts. So for the same, like the likelihood here, we have impacts. Okay, and impact has the technical impact. All right, and I'll just write the full word. Technical, so we have, again, 4 subcategories: confidentiality, loss of confidentiality, okay, loss of integrity, loss of availability, and accountability. About loss of confidentiality, which is, I think, one of the biggest impacts here. So how much data could be disclosed and how sensitive it is? Is it like minimal non-sensitive data disclosed, minimal critical data disclosed, extensive but non-sensitive data? Or is it both extensive and critical data? Extensive, okay. So extensive critical data, but not all of it. It's not like you just lost your entire database. It's a lot. It's a lot. Okay. So extensive critical data, that's a 7. There's actually a list of all those factors and how much they weigh. But you can also create your own. You can create your own categories too if you have something that's very specific to your business. Now, for the loss of integrity, that's more like a corruption, how much data will be corrupted and how much damage, Slightly corrupted data, like are they able to corrupt any data here through this vulnerability? No, it's more like leaked, right? Okay, so that means actually 0, because they only read, they don't write anything, so no impact on integrity, right? It's more like when somebody has access to the database and they can drop tables, then they can have a very high impact on your integrity. Do you get any loss of availability? And how important the loss? How vital? So are you going to lose any services? No, right? So it's read only. Okay. And accountability, that's, can you trace the threat agent's actions to an individual? If somebody tries to do this, can you trace it back to whoever did this? Well, if you're not logging that much and it's available to anonymous users, I would say pretty anonymous. Yeah, so that's a 9. So no accountability. They would steal it and you would probably never even know. Okay. And the second part in impact, that's the business impact. Financial damage. Reputation. Non-compliance with any laws. That's like if your credit card numbers get stolen, then you're not compliant with certain laws. And privacy violation, because people don't like their stuff, their information being stolen. Privacy violation. Especially on certain sites, you don't even want people to know that you have an account there. Some people. Right, so the business factors is how much financial damage will result from the exploit. Is it less than the cost to fix the vulnerability? So basically, it's so insignificant in financial losses that it's not even worth fixing. Okay, so that could be a business decision. Minor effects on annual profits, significant effect, and bankruptcy. Are you going to go bankrupt if this data gets stolen? Probably not. Okay, I see no's. Is it going to have a significant effect on your profits? It might. Okay. Or maybe more people would vote on minor effects. Minor or significant? 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 Okay, we get votes for significant. And I forgot the number. Significance is, where is it? 7. Okay. Reputation. So sooner or later people are going to find out that you lost all this information. So will this result in reputation damage that would harm the business? Is it going to have minimal damage? Are you going to lose major accounts? Are you going to lose goodwill? Goodwill is like how much more your company costs because you have good customer relationships and such. Or is it going to damage the brand? Sorry? High damage? Critical. Yeah. Brand damage is going to really tarnish your brand. Like you will not be able to recover from that. Yeah. Brand damage? Or you're just going to lose some accounts?
In my opinion, it's the brand damage. If you get the privacy of your customers or their shop habits, nobody will trust.
Nobody will trust you. Okay. What, may I ask what business you're in?
Books.
Books?
It's a bookstore.
Okay. So if my purchase of books get leaked?
Yeah, for example, you can have some strange taste in books and don't want anybody to know it.
Yeah, that's a good point. If I have weird fetishes, yeah, I might not want people to know. Luckily, most of my interests are in sci-fi and technical books, so good for me. If you buy a book about DOS, yeah, people might judge you for that. Yeah. Java 4. Woohoo! All right, so that will have brand damage. So that's like really, really bad. So 9, yeah? Big impact on reputation. I mean, it's just an exercise, right? It doesn't have to be accurate. And you should also not, one thing, not spend too much time of this in real life because this can be lengthy. So if you see certain things that are really easy to fix, you can just go ahead and fix them. Only when something becomes a bit more involved, then you have to, like something that would require maybe weeks of effort, then it's worth the time, worth the hour to go through that exercise. Okay, so just pessimistic but pragmatic. Now, non-compliance. So is it a minor violation, clear violation, high-profile violation? At least in Europe, yes, it is. So that's a 7. I don't know why there is no 9, but yeah. Non-compliance is a 7. And how much personally identifiable information would be disclosed? One individual, hundreds, thousands, or millions? How many customers do you have in your database? Thousands? Thousands. Okay, so thousands, that's a 7. And from this, what we do is we add them up. Okay, we're going to add up all the categories. We're going to do an average. So 959, and you have to help me, my brain is dead. 23 divided by 4, roughly 5 something. Yeah? Actually closer to 6. Okay, so that's a 6. Discovery 99663, that's 27. So that's divided by 4. It's closer to, well, no, because 23 came to 6. So yeah, just use the calculator. So 27 divided by 4. Someone. 6. Okay, so it's 7. Okay. 7 and 9, that's 16 divided by 4. That's a 4. So that's 21. 30. 30 divided by 4. That's 7.5. So that's an 8. Okay. So that's what we get. And then we have this interesting diagram. So of course, we can say if it's low, medium, high, and critical. Forgot what the thresholds were here. Do you have this slide with the threshold? Okay, so let's put the thresholds like this. 1, 2, 3, 4 to 6. 6, 7, and 8, 9, or maybe 6, 8, and then the 9 will be critical, okay? I don't have the exact. So this is basically, we're going to call it, we have notes also, so maybe 1 here and 2 to 3. Okay, so we have 1, 2, like this, like this, like this, like this. So we have 5 levels. Okay, so this is a 6, so that's 1, 2, 3, that's a medium. Okay, 7, that's also, that's a 7 to 8. So this is 7 is high, 4 is here, so that's medium again. 8 is 5, high, yes. Okay. So, based on that, we just plot it on the chart and we look at that. So, actually what we can do is take the 6 and the 7 together. Okay. So, we can actually add all them up. So between medium and high, that's a high. And this is, actually 4 is rather lower, so it's a medium. Okay. So you have high likelihood. Okay. High likelihood there on top. So last column. And we have medium impact. So that the overall risk is high. Okay, makes sense? So basically, well, we could have just added all these 8 instead. So I just did the average there. So basically, if 1 is high, you just find the intersection there. So the overall risk is high. Okay? The severity of the risk is high. It's severe. So what you do is, of course, once you have a number of those vulnerabilities identified and classified, what you do is you order them by priority. And of course, you're going to address any critical things first. And then you're going to address all the high ones and the medium ones, the low, and notes you might not even address. And basically, you stop whenever you feel like the threshold is acceptable. The level of risk is acceptable. Okay? And maybe by fixing some of them, you might reduce the risk for others. So you look at the critical ones first, but you still have to check the cost of fixing. Because even if it is critical, who knows, maybe the cost of fixing it is so high that it is still not worth it. Right, so some things may be so incredibly costly to the point where the business would just rather assume the risk. I mean, maybe it's more than the business makes in a year, so it's not even worth it. Even if they lose everything, it's still going to be cheaper than to take a loan to try to get this fixed. Is this? Okay, I thought the cable was doing weird things. And remember, it's not how many vulnerabilities you fix. You have to start with the bigger ones. So plug the bigger leaks first, and then go to all the small little ones. But of course, if you apply multiple countermeasures and you apply them in a way that makes it systematic, so if you make like systematic countermeasure, like binding your SQL parameters, then that will probably prevent a whole bunch of them. Okay, so once you figure that out, once you go through that model, you might want to refine it, because as you go, you realize that your needs are more specific, so you might want to add some factors. Like, as I said earlier, loss of life can be a factor. Let's say you design a system for ambulance dispatch. Loss of life is a very important factor and maybe might weigh more overall than the other factors. So instead of like divided by 4, the other one is going to be worth a lot more than a fourth of the category. So you add factors, customize options, and you change their weight of those factors. So you sort of create this heuristic formula that gives you more or less the answer you estimated in your head. So yeah, depending on your business, you might find different factors. You tune their options, the scores. Yeah, and as I said, some factors carry more weight. So for example, in some businesses, loss of availability can be a lot more disastrous than in others. So if a website is slow for a while, it's not a big deal. Like if it recovers in like 20 minutes, it's not the end of the world. Okay? In other types of businesses, that can be very important. Like if you have a downtime of 20 minutes, it's like your business is closed, right? So certain factors will carry more weight. Do you want to do another one? We have time, and we are almost done on the slides. Okay, let's do another one. Hopefully this one will go a bit faster. We had XXE. All right. Actually, let me just write it next to it in a different color so I don't have to rewrite all of the categories there. Let's talk about XXE. First of all, so we're going to grab invoices through XXE. Okay, so same vulnerability, or rather same asset, different vulnerability, XXE. So that's the XML external entity that allows you to access the file system and display anything. So who's the threat agent? Again, the competition. They're trying to grab your stuff. So the threat agent remains the same, right? So we don't have to change any of that. The vulnerability changes though. So how easy it is to discover an XXE vulnerability. First of all, do you process a lot of XML? It's not so easy. So will your competition be able to discover that? So they will need to be very skilled. Okay, so we can actually look at the threat agent in relationship to to that particular vulnerability. Actually, it does have an impact. So in order to exploit XXE, they need to find a way to feed you the XML of their choice, right? So they need somehow intervene in that process first. Excuse me? Right, right. So not only do you need to give them the XML with the injection there, but you also need to have the feedback that what you tried has worked. And you might not have control over that process. Maybe it's a daily process of importing data, so might require some iterations, yeah? Okay, so it's kind of hard. So the skill required for that is quite high. So I would put a 1 here maybe. Yes? Okay. The motive, I guess, remains the same. Still the same motive. Opportunity, if I go back. Opportunity is they need expensive resources or special resources, some of them, or no specialized resources. Do they need any specialized resources to try and exploit this? Yes? Well, we're not talking about knowledge. We're not talking about knowledge. We're talking about resources, like maybe they need some special device. They maybe need some processing power. That's a resource. Do they need any specialized resources other than knowledge itself? Because the skill level is the knowledge required. You don't need any expensive resources to try this, right? Okay, so that would be, let's say, why did we put 0 in the opportunity earlier? Huh? Yeah, but then we would have needed to put a 9. Anyway, we made a mistake, yeah? So the opportunity here is rather high because they don't need anything special, yeah? And the size of the group, anonymous users again, or how would they get the XML in there? They might need to know something about your system, maybe have some access. 1, 2, 3. I thought it died. Can you repeat? Okay. Okay. So they might need to be able to inject that. So maybe, well, first of all, it's going to have to be developers. Yeah. So we can reduce the size of the group. They need to have some sort of access to be able to deposit those XML files where they need to be. So that's kind of hard to achieve. How easy it is to discover? Not so easy. Actually, rather hard. Yeah? Because, as you said, because of the feedback loop, it's going to take so much time. It's actually quite hard. And once they do discover it, how easy it is to exploit. Again, if they are not able to put XML files anywhere for your consumption, then it's really hard. It depends really how those XML files are being read. Are they read from an FTP server, the same server? Are they read like through some remote access? And not remote access, but like they call a URL, so maybe you need to do like a man-in-the-middle thing and change the response they get. So it's going to be hard to exploit. Yeah? I can put a 1 here. Who votes for 1? Okay, we have quite a few votes here. All right. Awareness. How aware are people of that vulnerability? No. Okay. But do you have detection if something happens? Will you be able to detect that? But do you currently have something in place for that? Yeah, you have some sort of detection for XXE attacks? Okay. So you're saying that you currently have logs that would allow you to detect it? Okay. Okay. So is the detection at 3 or 5? Okay, we'll keep it at 3. Okay, you can already do the average for this for me while I continue the rest. Thank you. Technical aspects. Confidentiality. So the result will probably be exactly the same, right? Same loss of confidentiality. 7, same loss of integrity. Same availability, impact on availability and accountability. This has exactly the same impact. And the business, does it have the same impact again? Yeah. Okay. So it's only the likelihood that changes because of the attack type. All right. So 7, 9, 7, 7. So this remains a medium, and this probably goes down to a medium as well. Sorry? So we have 10, okay? We have 15, 17, 18, 19, 20. Okay, no, but if you just add those 8, that's what I'm doing. 10, 15, 17 plus 3, 20, 23, 23 divided by 8. So it's actually low. Okay, so low likelihood. Does that make sense with the assessment we made as we were talking about this? Yeah, makes sense. Because it's really hard to discover, it's really hard to pull off. Going through the URL is much easier than trying to inject some XML through whatever means. Like, we don't even know if it's really possible. In that case, we'll need to explore a bit. But yeah, this comes to a low likelihood and medium impact. And if we refer to the table here, overall, between low and medium impact, it's low likelihood, low severity. So we wouldn't have to worry about it too much. So even if it does exist, even if we do have this vulnerability, unless it's like 2 seconds to fix, if it does require you to go and review all your code to find that, then maybe you shouldn't bother because it's rather low. Or you do it after you fix all the other stuff. Make sense? Okay. So we can actually finish a little early. Some resources that will be interesting for you. That will be the OWASP risk rating methodology, so the one that we went through. It explains things in more details, give you all the numbers associated with different factors, the threat factors, all these numbers we pulled out. You'll have those numbers and you can tweak them to your liking. Top 10 2017, so that is actually you have them by several years. What you do is you the categories that I showed you, you can go through them and see examples, additional examples of the different vulnerabilities that exist, so classified by similar categories. I combined 2013 and 2017 in this presentation. And the last one is actually irrelevant because this is not adapted to Python, so you shouldn't have to care. Move. And I go back. Yeah, and I will create a PDF of those slides. I will put it on the Slack channel in the PHP track. And do you have any questions? Or something you would like to discuss? How do I protect myself against DDoS? Well, first of all, there are many ways. First of all, I need to have some sort of logging, so I would know that it's happening. So I can adjust, every application is different. and every application will respond differently to different types of attacks. Sometimes it will be an attack through an API, sometimes something else. A few things I really like is, of course, fail to ban. So like put some rules to quarantine IP addresses that are actively attacking. It's like it goes out for moments, yeah? Yeah, weird. Yeah, so I have failed to ban some automated tools that basically track this kind of behavior. With APIs, what I really like to do to prevent DDoS attacks is even if the request to the API is for public data, I still force people to create API keys to access that. A bit like Google or anyone else. You'll need a key regardless of whether you're accessing anything that's private. Because what the key allows us to do is to sort of put an identity to the request. And if somebody starts to hammer you with requests, what you can do is ban those keys. So if you see that one key is just continuously making way too many requests, you can put a threshold and you can ban it. And actually, when you do ban it, I would recommend that you use something like Redis, where in memory you can put your banned keys so that you could drop requests before they even reach your application. So instead of bootstrapping the application and start verifying the key, against your database and basically consume a lot of resources despite the fact that you will not want to serve that request, you put those banned API keys into Redis, and when something comes in, even before you start your API, you detect those keys and you're like, oh, you're one of those. So yeah, just cut the connection as early as possible. Okay, so try to find a way to waste as little resources as possible on those requests. And of course, banning IPs is like even a level higher where it doesn't even reach any of your application code. It's really at the server level. Does that help? Yeah, some ideas to implement. Any other threats, vulnerabilities? Yes? Yeah, so basically you're talking about combining XSS attacks with other types of things you can exploit. So you can, with the XSS, now that you have injected JavaScript, you can read cookies. Yeah, you can actively send out valid session IDs to some remote URL. So combine those vulnerabilities and really XSS. If the site is vulnerable to XSS, there's just so many things you can do. It's amazing. Like you can inject code that does pretty much almost anything you want. Okay, within the limits of the browser. So if the browser has access to that through JavaScript, you can access that. You can access local storage, you can access all the things. You can access camera even. It's really up to you. It's XSS is very powerful, yes. Right, so if you use like the native, if somewhere it's using the native unserialized function, if it's using that, so I mean by default it will deserialize, that's what it's going to do. So you don't even need any special flag. If you are calling unserialize on something, then that's it.
So the most stupid example, we have something that is serialized and stuff in database. So if I would have an access and to change something database, I really can like use the same trick with deleting file.
Exactly. So the trick I showed for deleting the file, I'm repeating for the camera. So the trick I showed for deleting a file through YAML deserialization. If you store a serialized object in the database and somebody is able to modify that serialized data, once you deserialize it, it's going to get instantiated, it's going to call eventually the destruct method, and it's going to be able to do the same thing.
Global is like even two vulnerabilities. So the one is serialization, and the second one is if something is not escaped directly. I mean, parameter reading, for example, is right somewhere. So with the serial injection and this serialization stuff, it will happen.
Yeah, you can also combine that with an SQL injection. So through SQL injection, you can make sure to store something. If you know that this piece of data is going to get deserialized, you can craft a careful query to additionally insert something into the database that is harmful, like the YAML bit I showed. So you insert that object, and you call the page that it's going to cause the deserialization of that exact object, and you're in business. Yeah, so combining those vulnerabilities is actually where the real fun is. Not that you should do it for fun, but I mean, I'm having a lot of fun coming up with real life examples, things that can be used in reality. It's like, oh well, let's look at a destruct function that exists anywhere in any trait, any class. What can we do with that? And I try to come up with a real life example, and I'm like, oh, I could do that. Yeah, I find that fun. I mean, just the intellectual exercise is fun. And of course, we learn so much. Because we use such complex frameworks with so many classes and traits, there are a lot of classes, a lot of objects potentially available to us. A lot of those destruct methods that we can trigger through that vulnerability. Any other remarks? Questions? You guys are tired? All right. Joining for drinks afterwards? Drinks? All right. Awesome. Okay. Well, thank you very much. I'm going to let you go early. Enjoy the drinks.